I want to start with actually a small information to this video. I want to show you that if you go to F20 Math 101 all sections, if you go to the general page, and if you go to class notebook, okay, if you open that up, you will be able to see the review class or our virtual class notes in there. Okay, so I'm gonna do that. I want to open up in browser here. Actually, I'm gonna open up in desktop application here. Okay, this page opens up, and I'm using this collaboration page, which you can see all these notes. And today we are going to go over some review. Let me see, I'm trying to find where to start with. Okay, we are going to solve the question 3 in homework 4.2. It says show that f of x is equal to square root of x plus square root of x plus 1 minus 4 has exactly one root, 1, 0, in this interval. Okay, part 1. In part 1, we have to show, we show f of x is equal to 0. F of x is equal to 0 has a real root. We have to first show that it is a real root, and then in part 2 we have to show that it doesn't have more than one real root. Okay, this is part 1. Alright, so we use intermediate value theorem. We use intermediate value theorem to show that this is chapter 2. In chapter 2, intermediate value theorem we have. Okay, intermediate value theorem. And how do we do? We find 2 points where f takes negative and positive values. So I'm gonna choose, since this is 0 to infinity, my numbers has to be bigger than 0. So if I plug in 1 here, 1 and square root of 2, 2.4. Okay, yeah, let's use f of 1. F of 1 is gonna give me 1 plus square root of 2 minus 4, which is square root of 2 minus 3. But remember, square root of 2 is approximately 1.4, so this is definitely less than 0. And let's use f of 8 maybe, yeah, or even f of 4. It's gonna be 2, 5, yeah, definitely bigger. Let's use f of 4. F of 4 is square root of 4 is 2 plus square root of 5 minus 4. So this is going to be square root of 5 minus 2. Square root of 5 is bigger than 2, so this is definitely greater than 0, right? Square root of 5. Let's see. Square root of 5 is bigger than 2 for sure. Okay, so we found 2 points where it's going to take positive and negative values. You can consider that pictorially it's like this. So we have 1 here, we have 4 here. At 4 we have a positive value here. At 1 we have a negative value, and the function needs to go through that because it's continuous. So there's a c here, okay, that it's going to go through the x-axis, which means it becomes 0. So we say that by intermediate value theorem, there's a c, there is a point c in 1 to 4, actually open 1 to 4, such that f of c is equal to 0. Okay, next, so we proved that there's a real root. Part 2 is it's the only one, there's no other. Okay, part 2. All right, we we don't have more than one. We don't have more than one root. Okay. Okay, how do we show that? We assume the opposite. We assume this is not true. True. And this is not true, and we get a contradiction. And we get a contradiction. This is called a proof by contradiction. Okay, proof by contradiction. How do we do that? So we assume there are 2 points including one of them C. Let's call them C1 and C2 in 1 to 4 such that f of C1, let me erase that. F of C1 is equal to f of C2 equals to 0. Okay. We in part 2 we use Rolle's theorem to get a contradiction. Okay, we recall Rolle's theorem. Rolle's theorem. F is continuous. F is continuous. And differentiable. Okay. Here actually f is differentiable. If you take the derivative of this, you get 1 over 2 square root of x, but 0 is not included, so it's differentiable. And this is, you get 1 over 2 square root of x plus 1. Then you take the derivative, x plus 1 is a differentiable function unless x is -1. Since the domain doesn't include 0 and negative values, this is differentiable. So obviously, okay, continues on 0 infinity, and differentiable on there as well, and differentiable on 0 infinity. Okay, since f prime at x is equal to what? 1 over 2 square root of x plus 1 over 2 square root of x plus 1. And what's the term? Last term is number. Let's see. Yeah, and it's 0, right? Okay. See, this is not differentiable at 0 and -1, but none of them. Okay, 0 and -1 is not in the domain. 0 and -1 are not in the domain. If they were in the domain, then that would be a problem. Okay, so we can apply Rolle's theorem. We can apply Rolle's theorem, because for Rolle's theorem we need these two things. We need 3 things actually. We need this, okay, Rolle's theorem, and we need f is continuous, and we need f is differentiable. Okay. Okay, so this is continuous on here, of course, on this interval. Okay, so we have all that. Therefore, we can apply Rolle's theorem. Says if you have that, okay, pictorially it's like this. we have C1, we have C2, and F is 0 here and here, right? F of C2 is equal to 0, F of C1 is equal to 0. So there's at least one point where we are going to have a horizontal tangent line, like in here. Actually, in this picture we have more than one, but one is enough. So by Rolle's theorem, there is a D in this interval in such that C1 less than D less than C2. Okay, in this interval, let's let this to be D, such that F prime at D is equal to 0, horizontal tangent. Let's get back to our F. So let's check whether this is true for our F. But we found F prime at X is equal to 1 over 2 square root of X plus 1 over 2 square root of X plus 1. And is this ever 0 in here? Okay, let's check it out. This is not possible because this is always positive. Strictly greater than 0, this is always positive. Positive number can never be equal to 0. So we get a contradiction. We get a contradiction. Okay, we get a contradiction to what? To the assumption. Assume there are 2 points. Let me circle it in green. So that was the assumption. We get a contradiction for this. Okay. We get a contradiction for star. About. Okay, then this would mean for us that we cannot have more than 1. This implies that we cannot have more than 1 root. So we must have exactly 1 root. We must have exactly 1 root. Okay, done. Alright, so we got that. And let's look at this. The question says, this is homework 4.2, question 5. Find all possible functions with f prime is equal to this. So we are asking ourselves for which f, or for which, let's see. So we have to choose an f such that the derivative is going to be this. So we are thinking the opposite way. So it has to be sine first of all, because the derivative of sine is cosine, and we are going to have 2t here too. Take the derivative of sine, you get cosine. If you take the derivative of the inside, you have 2. We have to get rid of that, so we have to multiply this with 1 over 2 so that it cancels. And here, the derivative of cosine, negative cosine is sine, so it should be negative cosine for sure, negative cosine t over 2. But if you take the derivative of this, you get 1 over 2, but we don't have 1 over 2 here, so you multiply by 2. Okay? But it says find all possible functions, so we are going to put a big C. This is a constant scalar. So this is gonna include all of such numbers. Okay, so let's get this. Homework 4.2, question 6. It is there's a body and that's moving. Its acceleration is given. Acceleration is minus 49 sine 70. and the initial velocity is given, initial position is given. They're asking about find s of t. So this is okay. So we know, okay, we know that the velocity is equal to ds dt, and acceleration is equal to d squared s dt squared. Okay, we know that. So we have to go backwards. So we have s here. If you take the derivative, you get v, and if you take the derivative, you get a of t, v of t, s of t. This is the position function, this is the velocity function, this is the acceleration function. You take the derivative, d over dt, and you get that, you get the derivative. Okay, to go backwards, you ask yourselves for which function it should be such that you should ask the opposite question. The derivative is going to be equal to that. So for this one, okay, so let's try to find v first. So our acceleration is negative 49 sine 70. So we ask ourselves, since this is sine, it should be negative cosine 70. I mean 70 here. If you take the derivative, you get 7 in the front. So our answer should be this. Okay, let's check it out. I mean plus a big plus c1. Okay, let me erase this, clear this up. Okay, so this is going to be t plus c1, a constant. Okay, so v of t is going to be 7 cosine 7t plus c1. Let's check the answer. Take the derivative of cosine, you get a negative sign. Take the derivative of the inside, you get times 7. 7 times 7 is 49, so this is good. The derivative of c1 is 0, so this is okay. But we need to find c1. We are given v of 0. V of 0 is, let's go up here, v of 0 is 7. Since v of 0 is 7, we put in the value 0 here. 7 cosine 0 plus c1 is equal to 7. This is 1, so this implies that c1 is equal to 0. Okay, so now we know what v of t is. V of t is 7 cosine 7t. That's it. I mean, just a sec. Okay, so this is our v of t. Now I'm going to go backwards one more time to find s, and I ask myself for which s, let's see, if I take the derivative I get that s of t is equal to the end, it should be sine 7t, yeah? Okay, if you take the derivative of sine, you get cosine, derivative of the inside 7, so this is it, and I'm going to call plus c2. Okay, and what is c2? We need to find it. What is this? Okay, s0, we go back to s0. S0 is negative 1. Okay, s0 is sine 0 plus c2 is equal to negative 1, but this is 0, so this tells us that c2 is negative 1. So I found s of t. S of t is sine 7t minus 1. Okay, I got that as well. Done. Alright, that's the answer to that. Let's look at this question. This is question 8, mean value theorem. By mean value theorem, we have such an inequality: minimum f prime less than or equal to f of b minus f of a over b minus a less than or equal to maximum f prime for any interval a b, where f prime is continuous. And we are given f prime as the following: 1 plus x to the 4 cosine x. F of 1 is 4. Use the above inequality for x1 to 1.2 to estimate f1.2. Okay, that's what they are saying. Alright, so we are going to get that. Okay, here first of all it says you can use this inequality when f prime is continuous. We want to make sure that this f prime is continuous, right? Okay, the question is f prime continuous on, okay, is f prime continuous on okay 1 to 1.2, yeah. Okay, so actually including this, yeah. And this is the question, and the answer is actually, okay, remember cosine x. Okay, what's the graph of cosine x? Let's remember. So the graph of cosine x is, if you remember, it is like this, right? And then this is 1, this is pi over 2, because at pi over 2 to 0, and this is pi when this takes the -1 value here. Okay, now the question is, what is pi over 2? What's the value of radian pi over 2? Pi over 2 is approximately 314 over 2, which is bigger than actually 1.5. Okay, bigger than 1.5. So in other words, actually our interval 1 to 1.2 is somewhere here. 1 and 1.2 is somewhere here. 1.2. So we are in here. Okay, because of this, our graph is actually positive. So cosine x is positive here. Okay, since cosine x is positive, so x to the 4 is also positive. So x to the 4 is positive on here, and cosine x is positive on here. So if you multiply them, their multiplication is positive. So this implies actually 1 plus x to the 4 cosine x is positive. Okay, so the denominator is never ever 0. Okay, therefore it's continuous. Okay, this implies, okay, this implies f prime is continuous on 1 to 1.2. So we can apply, actually we can apply inequality, the given inequality. Okay, so if you apply it, you just copy. It says minimum f prime, maximum f prime, and this mean value ratio is squeezed in between. So okay, so let's write minimum f prime is less than or equal to, yeah, f of, so I'm going to apply this to here, 1.2 my f of b minus f of a, f of 1 over 1.2 minus 1 less than or equal to maximum f prime. Okay, so they're asking us to approximate f1 to f1.2, so they're asking about this. Okay, and this is actually given to be 4, I guess. Let's go up here. Yeah, 4. So we put it in. This is given as 4. So what is maximum f prime? What's minimum f prime? We have to determine. Okay, so we said that this ratio is positive. So the minimum value is going to be when x to the 4 cosine x is 0. Okay, or in other words, let's look at this picture. Okay, whenever so we are in here, right, cosine values. So 1 over 1 plus this is going to be taking the biggest value when, okay, next question is, how are we going to find minimum f and maximum f? Okay, how do we find, okay, that's right, how do we find minimum f prime and maximum f prime? F prime. So actually you know how to do it. So first of all, we want to make sure that we want to know how this function behaves on 1 to 1.2. Is it increasing or decreasing? How do I know? I take the derivative of f prime. So f prime is equal to 1 over 1 plus x to the 4 cosine x, yeah? Okay, let's get back to it. Yeah, that's it. So let's take the derivative one more time. If the derivative is negative, okay, if the slope is negative, it's decreasing. If it is positive, it is increasing. So, but you can look at this as 1 plus x to the 4 cosine x. Raise it to the power negative 1. So we have negative 1. This is the power chain rule. X to the 4 cosine x, decrease the power by 1, times it with the derivative of the inside, 4x cubed, cosine x, product rule, okay, minus x to the 4 sine x. Okay, alright. So we get what? So we get negative 1 on top and 1 plus x to the 4 cosine x in the bottom, square it, and also we have this term which is 4x cubed cosine x minus x to the 4 sine x. Okay, so when you look at this expression, so how am I going to compare cosine x and sine x? Is this positive or negative in 1.2, between 1 and 1.2? If I plug in, okay, let's find, okay, I'm interested in is f double prime negative on, okay, 1 to 1.2, yeah, that's the question. Okay, what I could choose is I can take a point, I can try 1 at 1. What is it? At 1, this is cosine 1, this is sine 1, 4, so I'm gonna choose some numbers here. Okay, I look at x is equal to 1, I have 4 times 1 cosine 1 minus sine 1. Okay, so is this a positive number or not? So I can try on Wolfram alpha, and for example I take x is equal to 1.1, 4 1.1 cubed cosine 1.1 minus 1.1 to the 4th sine 1.1. So I want to know whether this is less than that, or I mean whether positive or not, this value. So I can go to Wolfram alpha and check it out, try that out, or I can directly draw the graph. It seems actually this is going to be positive. Okay, I checked it out. So this is a positive value, this is positive on this interval, this is of course positive, so this is negative. This is going to tell us that this is negative, but of course you have to check this on Wolfram alpha. Check positive or negative, positive or negative on Wolfram alpha to say that, and I checked that that's true. Actually I did this too. I just went to Wolfram alpha and drew that graph. So if you draw that, if you draw this plot 1 over 1 plus x to the 4 cosine x, which is f prime on 0, 2, and you're gonna see it's a decreasing function between 1, okay, 1 and 1.2. Look, it's a decreasing function here until here. So it's a decreasing function, you can see it here too. Since it's a decreasing function, it's going to take its maximum, okay, it's going to take its maximum at 1, and it's going to take its minimum at 1.2. So after looking at the graph, graph of f prime, actually you could have looked at the graph of f prime right away instead of going through this taking derivative stuff, but I thought maybe it could be easier to see it, but it's not. Okay, so f prime 1 is the maximum value, maximum of f prime, and f prime 1.2 is the minimum of f prime. Yeah, okay, so on this interval. All right, so so we are going to put it in. we are going to approximate. So let's get back to this inequality, and I'm going to write it in here. Okay, let's use a different color here. Okay, so minimum f prime is f prime 1.2 less than or equal to f prime 1.2, I mean f of, I'm sorry, they're asking about this. Okay, minus f of 1, which is 4. 1.2 minus 1 is 0.2 here, less or equal to, maximum is f prime at 1. Okay, so we need to find these values as well. Okay, these values are easily can be found. You just plug it in. So this is 1 over 1 plus 1.2 to the 4th power cosine 1.2. Okay, less than or equal to, okay, f of 1.2 minus 4 over 0.2 less than or equal to f prime 1 over 1 plus cosine 1. Okay, these values can be found from Wolfram alpha. And from here we just isolate f 1.2. Okay, multiply both sides with 0.2 first. Okay, so I'm going to multiply both sides with 0.2, and I'm going to multiply this with 0.2 as well, and multiply this with 0.2, and these are going to cancel. Okay, and then I have 0.2 over 1 plus 1.2 to the 4th power cosine 1.2 plus 4 less than or equal to f of 1.2 less than or equal to 0.2 over 1 plus cosine 1, excuse me, plus 4. Okay, so these numbers are f of 1.2 is bigger than or equal to this number and smaller than this number. We can use Wolfram alpha to find these cosine 1 and cosine 1.2, but I'm gonna leave it at that. And let's go back to the original question and estimate f1.2. The estimation of f1.2 is between these two values, so it takes any value between this value and this value. Okay, all right, so I'm gonna just write done. Okay, and then let's move to the next one. Find the values of C that satisfy mean value theorem for f of x on here. Okay, so let's remember mean value theorem. Okay, this in order to apply mean value theorem, f has to be continuous and differentiable. Actually it is true because look at the f prime at x is 6 minus 6 over x squared, and this is well defined on the domain. Let's call this D, domain D. Okay, this is domain D. Okay, well defined on D, so f prime is okay, so f is differentiable. Okay, so actually f is differentiable on the open interval 1 over 20 and 20, and f is continuous. It is continuous because no bad points on this here. Okay, so the two conditions of the mean value theorem is satisfied. Okay, condition 1 and 2. Okay, condition 1, condition 2, both of them checks. So we can apply mean value theorem. Okay, and the mean value theorem says this. Okay, f of 20 minus f of 1 over 20 over 20 minus 1 over 20 is equal to the derivative of f at a point C. C is in this interval. Okay, alright, so they're asking about finding all values of C that's gonna satisfy that. Okay, what's f of 20? Let's calculate f of 20. It's 120 plus 6 over 20. Okay, let's write it down. 120 plus 6 over 20 minus, if you use 1 over 20 instead, okay, 1 over 20, 6 over 20, the same thing actually, right? 1 over 20, it's just the reciprocal. If you put 1 over 20, you get 6 over 20, it's symmetric. Alright, so you get minus, okay, 6 over 20 plus 1 over 120 over 399 over 20. Okay, they're asking about f prime c, but this is 0. So we are going to find all values that f prime is equal to 0. Find all c such that f prime at c is equal to 0. Okay, so what is f prime c? We took the derivative above, if you remember. It is, to see this differentiable, it's 6 minus 6 over x squared. So let's write it in. 6 minus 6 over x squared. So equate this to 0. Okay, so this is 6x squared minus 6 over x squared is equal to 0. Okay, for which x this is true, x squared is equal to 1. Okay, x is equal to minus plus 1. Okay, but we have to look at the domain. It has to be in the domain. Okay, maybe I shouldn't say x, sorry about that. It should be c. I have to change it to c. Okay, this is c squared, this is c squared, and this is c. But if you consider the domain is positive, so c is equal to 1. So we found all, there's only one single c that satisfies, okay, there's only one c which is equals to 1 that satisfy mean value theorem. Okay. Alright, so that's it. Okay, let's get the next question. I think that's all we have for 4.2. So we are gonna work on 4.3.